is now going. You can start.
Yeah. So, hi everyone. In today's open office call, we thought that it might be a nice idea to implement a extractor strategy, and so we'll try to do that live. Actually, I've not tried to do that at all, so we'll see how it goes. In general, I think you can ask questions, but probably most of the session would be me talking, I think, and with the idea that in the end we have. I think the outcomes should be that we have some code that I can share on GitHub as a PR. Probably not going to be finished, and then I think another outcome should be where, like any of you that are in this call, if you have questions or just that you reach a better understanding of how this can be done and so on. So unless there is right at the beginning some questions or comments or whatever, then we can just start. But yeah, I want to open up the floor. So if anyone wants to say something, wow, we have a lot of people.
I mean, I think from my perspective, that sounds exactly what I was hoping for. So yeah, unless there's any other questions, I reckon we just dive into it. Cool.
Okay. Yeah. So I've already prepared. I mean, I've anyways just looked at the contract. I think so. In general, the Mint Songs v2 contract is proxied. So, and it's basically the proxy implementation is in that link here. Now, one thing already that I haven't figured out, and if someone has an idea, is why I cannot query the token URIs directly from the underlying ERC-720 contract. I have though found that it is possible when querying directly on the proxy. So I think we can just probably use the proxy itself. But yeah, again, I think it would probably be better if we did the queries directly on the underlying contract. Because anyways, I think our implementation of the extractor will break if we query through the proxy and then the proxy gets updated. But in general, just to make you understand basically how these things work. So we have the core repository on GitHub New Network Core, and then that can be installed. Essentially, you have to just mine the prerequisites. And then a bit of a specialty is that in the source folder itself, we have this Git submodule that points to a specific commit of the new network strategies repository. And then in here, similar to snapshot.org, we allow anyone to implement their platform's strategy as a way to extract. And we are segmenting the task of extraction and transformation of the data, and then later we'll also segment out the task of loading the data into a database. So generally, we always have an extractor and a transformer, and the extractor is there to handle basically the inputs and outputs. So it's like directly querying files from the file system and trying to store those files as fast as we can on disk, and ideally with as little transformations as possible, because in accessing this data and trying to transform it, we are also introducing the risk to errors, and so we want to minimize the amount of errors. And then in the transformer strategy itself, you can see that we are basically we have downloaded a certain item, and then we are normalizing it into, let's say, the new schema. So how this looks like, if you have ever run New Network Core, you can see that we have a data repository, and then this data repository is segmented into different files, I think if you don't want to, oops, that was the wrong one. If you don't want to run the crawler, or if you don't have the means to run the crawler, that can also be. We are continuously publishing the results of a crawl on GitHub. So this is essentially exactly the data deal that you would get if you run Noob Network Core today, I think. And basically, each of these files represents a state of the crawl of a certain strategy. So this is the strategy sound, XYZ call, token URI, and this is the extractor. This is the transformation of that. And then I will probably have I will have to download this, but basically what you can see here is that this is just a bunch of like data essentially. Now, for Mint songs, and I want to be conscious of time, what we want to do is, I mean, this is not ideal, but just to demonstrate, I think the kind of the extractor strategy is we want to just we want to enumerate through the contract. So we want to start with okay, so they start with 1, and we want to just go to 2, 3, and so on until we again like hit a limit in terms of the token URIs that we can query. So yeah, it's gonna be less than 150. And the goal should be where we are downloading just the IPFS links here, and then at a later stage, and this is not something we're going to do today, but at a later stage we could then also look behind what is behind those links, and we could download those too. And over a longer period of time, this would then end up in the final outcomes result. Now, we already, or maybe until now already some questions.
Not from my side. I don't know if anybody else has any questions. If not, then...
Okay. Then,
it seems like no.
Okay. Yeah, then I just continue. So we already have a strategy that is fairly similar, I think, to the strategy of like enumerating Mint songs, and I just want to go into it. So the other day, what we did, just to make an example, is we implemented a get xkcd strategy. So xkcd for the uninitiated is a webcomic about like nerdy stuff, and usually any of these, they have some kind of like a number. So yeah, you can see there is a number, so it's also enumerable. And so essentially, I guess to understand like how these extractor strategies work, we can just like look at how they are implemented and what kind of interface they need. So I think what is interesting to see is that we are exporting 2 constants. One is name, the other one is props. Then we are exporting a function init, and we're exporting a function update that gets an input called message. And this message seems to have like some kind of structure. So there's an error here. And then similarly for init, for example, we can have this like start variable. But there's actually more to this. So we are quote unquote formally defining an interface. We're actually looking to define this properly with TypeScript at one point also. And so you can see that there's like an underlying interface, and then as the extractor implementer, you're supposed to basically implement the structure of this interface. And then what this allows you to do is what this allows us to do is to call your extractor strategy, at a certain time, with certain parameters, or just like this a certain a function call, so whatever. And in general, the extractor strategy interface has been built according to the old way of writing React components. So if you remember back in the days, there was always a in order to build this React component, you had to have a class, or you had to use this like create class method or function, and then you had to implement this function, for example, called component did mount and a render function. And this is kind of like the same principle. I think also back in the days with Objective-C for iOS programming, you had a very similar pattern where you were defining the life cycle basically of a component. So here it's very similar. The extractor's init function is called once in the very beginning when we boot up the extractor, and then there's this object, and in the object we can pass a list of messages, and then we can also pass a string that gets written. And then actually what happens after this message is being executed is Noom is gonna invoke the update function per message. So we can do something with the message, and then we can pass some more messages or write some more stuff to the disk. So that's actually I think that's the as a gist, like the life cycle. There is also a sequence diagram if you're into that kind of stuff. So you can see, I think, how that would work in detail. But in general, I think we can just like look at how this would work in reality, where we have the XKCD API, and it's returning JSON. So if we replace the number here, then nothing happens, because apparently they are not starting at 0. But if we look at the 100 XKCD, we can see that the number is correct and that there's like a title and so on. So essentially what this strategy, all it does is, at first the init function is called, start is set to 0, and actually that might be wrong because it should probably be 1. And then it's just sending one message. The message is of type HTTPS. The strategy that is commissioning the message is the name of the strategy, so get XKCD. There's a version. There's a URL that we're passing, which we're getting from this function that generates a URL with the number. Then the HTTP method, and then we have two nullified properties, one called results and error. So essentially what this does is, like one of the problems I think with crawling data is that you want to have some form of like concurrency, and you also, since it's like input and output, one of the problems that you're having is that a lot of things can go wrong, like the internet connection might not be stable, or like someone might rate limit you, and so on and so forth. So what we try to do with Noom is we try to remove basically the complexity of like crawling APIs, and we are leaving that to a component that is called the extraction worker. And so really all of the distributed systems knowledge, or the knowledge about like complicated API stuff, this should happen in here, and it is happening in here. And essentially the strategies are communicating with the extraction worker, which runs, I guess you can think of it as like it runs in a different thread or a different process. They are all communicating through this like through this different through this message schema. And then the message schema itself, to catch runtime errors, we are also publishing that as a JSON schema. So you actually can see that that there needs to be a well-formatted structure to this HTTP object, to this HTTP type object. But we are not only supporting HTTPS, but we're also supporting the graph and JSON RPC. So I think we probably want to get started with this. And I probably have to just like figure it out. So I think so for example, we cannot use HTTP as here. I think we should use JSON RPC as the type, and then we should make the call directly to token URI. So one call where we are doing something similar is with Zora, where, for example, we are already defining the call signature here. So I'm just quickly gonna basically let's create a new directory and let's call it call MintSongs v2 token URI. Oops. And we already know the call, the Ethereum static call signature. It's the token URI, and we're just gonna copy that over from. Oh God. We're just gonna copy that over from Zora. What is happening? And we're just gonna add it as a constant here. And we are closing these brackets. Then I think we can get rid of the template URI because we're not really using the XKCD comics anymore. But I think what we anyways wanna do is we wanna have a URI, and it should be the URI of the JSON RPC, that endpoint that we are wanting to use. And actually the Noom network core library gives us a guarantee on that. And so basically in an env variable, it makes the URI available. So what we can do is just in the environment variables, we can okay, now I shouldn't open the env variables. I was about to open the env variables, but I think they are called. Okay, how do I do this without doxing my credentials? I go here and look at the env copy. So the variable would be RPC HTTP host, and then the API key would be RPC API key. For the sake of time, I will just also copy that from here. So essentially we have like a fully working options object here, and we also want to get our authorization headers from here. Man, I don't know why I have this swap file, because I don't remember having any of this stuff open. Okay, so again, I'm getting the authorization header, and if it's available, basically we'll add it to the options. Then here in the options itself, we'll just say these are the options, and we are changing the type to JSON RPC. And what else do we need actually for doing an RPC call? Okay, so we need to define also the method. So it's going to be an ETH call. And yeah, we also need actually the parameters of the ETH call. So if you are wondering where you would understand how to structure this like ETH call thing, we are not using any of the commonly known Ethereum libraries, but we are using our own stuff. So it's called Ethereum ETHFun, and it stands for Ethereum Functional. And so this library, the idea of this library is to not introduce any intermediate state, which I think Web3 and Ethos they're doing quite often. So I think in Ethos you have like this class-based approach where you're like building up this like stateful class of all of the different contracts and providers that you're using and so on. And if_fun is really is different in the sense that you would pass everything to the function itself, and the only state that it has is like keeping the request open, and then it just shuts down. And so essentially we are using in if_fun, we are using the apparently this doesn't work. We're using the call. We're using the call, and that's essentially doing a static call to the Ethereum node. So it's not it's basically a message call. So no transaction is necessary. It's just calling a function essentially, and that's implemented in the extraction worker. But essentially, what we have to do is we have to define basically the options. So these map, I think, quite one-to-one to the options in the message schema of Noom, and the to and the data. So for the data, is actually I would say the data is probably the most challenging part. So we already have the signature, and actually I'm noticing that this signature subname is not necessary, so we can also just do it like this. And in order to create this data, what we'll have to do is we'll have to encode a function call, and that is actually implemented with Web3 ETH ABI 1.4. And so we can look at the docs here, and basically we have to pass in basically this kind of signature that we already have, as well as the parameters in an array. So we can import encode function call from if_fun, and let's just make a like a lambda function that's called call template, and let's pass into it the token ID that we want to have in this call, and then basically let's call encode function call with the solidity function signature, and the token ID in an array, because I think that's what it expects as parameters. I'm not sure actually. It might also be that we can just pass token ID not as an array. And then we'll basically copy this params sub-object here. We'll have to make sure that data is the call template at the DARP number. Then we have some, I think, a few parameters that we should still try to understand what is happening with them and where we get them from. So I think in general the block number, for sake of time, this is essentially the block number tag that you're using to make the call, and we could make this like, I don't know, a specific block number when the NFT was minted, but I think for sake of like just demonstrating, let's just use latest here, which is the latest block on Ethereum. Then from usually defines who the call is made from, so that's important when you have I guess it's not when you don't call a pure function, which means that it might be that the function requires the message sender to be available. I'm honestly not sure if I'm currently a bit unclear if we need that. We might not need to define that. Yeah, so exactly. So here it is just set as null, which unless I'm missing something, I think that's how it should be. And then finally, I think what's also important is that we need to have the contract's address. So for that, we are using the proxy. And I'm also just going to define the address here as as the contract address here. And then let me check if we miss anything. So metadata is something that is non-mandatory to define. It's more a means to allow you to communicate between different calls of init and update. So we're not going to define it here. And for the sake of simplicity, I also don't want to implement update for now. So the expected outcome of calling this strategy should be where we just see one single token URI being returned to us, and then in a later stage we could implement the function update. But for now, let's actually try to test this. I hope I haven't made any severe mistakes. I'm just seeing that here the name is also wrong, so let's make it call MinSongs v2 token URI. v2 token URI. And then one of the problems is that how now do we test just this this implementation? I mean, one way, and probably the best way, would be where you write a test in here. But I think we don't really have time for that. So there's a little trick that you can do where basically in the end, I mean, Noom works by invoking different strategies at different times, and there's always one strategy that comes before all of the others. And this is currently, it's hard-coded into the lifecycle implementation. And as you can see, we are, as a first strategy, emitting the Web3 subgraph extraction strategy. So we can change that to call mint songs v2 token URI, I think, and it's an extraction strategy. And we can also define actually the start variable, so we could put a 12 here or a 0 or 1. But I think for now the variable, the default variable is fine. I'm now quickly checking if there's any questions and if I'm still live and everything. So yes, seems to be working. Does anyone have any questions at this stage?
No questions from my side, just to note that you are still live. And obviously you're going through stuff quickly, but I am recording it so people can watch back and stuff, so don't worry about that too much.
I'm going a bit faster because I think if I wanted to explain really the entire context, we would probably be sitting here even tonight. But okay, let's actually run this now. So to run it, as you might understand, we are here in the core/source/strategies repository, but actually the strategies repository itself cannot be run. So we actually have to do that from within the core repository that then takes the strategy repository to run stuff. And basically all the data goes into a directory that we are basically defining in the env variables. And again, I'm not gonna leak my credentials here, but instead go to the env copy file and show you that you can define the data tier as you want. Actually, you cannot, because we cannot link, I think, to absolute paths at this stage. But in for relative paths, I think you can define it into any subdirectory. And so right now, that is for me, that is the data directory here. And just to make it clear, I'm just going to remove all the existing files in here, and I'm going to check if it's empty. Yes, it's empty. So now let's run our strategy and see if something happens. And yes, so we have gotten a lock, and so that seemed to have worked. And actually, we have results here, and these results, don't be surprised, but actually is my 1 second is yes. Oh shit. So so my my API credential is in here, so I will have to change that after this call. Yeah, that's what I was already thinking. Anyway, so don't be surprised, because the Ethereum fun basically doesn't return you a formatted or a decoded string argument. It always returns the hexadecimal string. So that would have to be essentially would have to be decoded with Web3 ETH ABI. Now, we're not going to do that for now. I think what's more interesting and more important, I think, for now would be where we're like able to basically enumerate through all of the song Mint songs v2 Mint songs v2 token URI. So basically, as you can see, this function was called, and it's called essentially with a filled-in version of this message here. So where results basically is like this is suddenly like this populated object with all sorts of stuff in there, right? Including my API credentials, unfortunately. So so then in the second step, we can we have the same methodology to just send another message and get again and get this this function to be triggered again, the update function. So what we can do, if we pass the token URI in the metadata data field here, that will also be propagated. So I'm just going to put it in here. What we can do then is we can find a new token ID by looking at the message and at its metadata, at the token ID, and we're just going to increase it by 1 basically. So this means we're like going to start with 1, and then once we're hitting update, this is going to be 2, and then once this gets sent, basically it's going to come back in here again. It's already 2, so now it's 3. And so on, 4, 5, blah, 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 and so on, until basically we're like, I guess, hitting a limit. Now, what we'll have to do here is we'll have to change the number to call template. So we'll call this new token ID. And then I think it would also be nice if we would start writing stuff to this. So we can do that by using the write keyword on the return object. And let's just write the results. And I'm wondering if I've been missing something. I think this should work, but let's also, just to show this visually, let's console log it. Yeah, let's just, I think we should just try it. So, okay, so I'm already seeing that we are getting an error here that says cannot read property of token ID of undefined. And so I'm suspecting where this is coming from. And I think it is coming from the fact that we haven't defined metadata in the update message. So I think now this should return better results. And okay, and it should not be start, but instead should be new token ID. So when we run it now, yeah, we can see that now the queue is like running, and there's basically new things like appearing, and the total amount of tasks that it's processing is like 40, 50, and so on. And more interestingly, I think, we are also writing the results of those messages. So if we are like going into the data here, what you can now see is that we have a new file that is called minsongs v2 token URI, and you can see, although what is a bit weird, and I don't know why, it's putting these things in parentheses. These should be all different, and they are. So basically, these are all the token URIs as hexadecimals for each of the calls that we made. So I mean, as a first step, this would be the kind of logic where we can run through the different token IDs on MintSongs, and then as a second step in the transformer, and that would be this would be an additional file like here, right? Or would be like a different file, like like it is like here, like this kind of file. As a secondary thing, what we would have to do is we would have to decode parameters. So essentially, the parameter that we're getting back from token URI is a string. And so in where is it? Here. In decode parameters, basically, what would be required is that we say, okay, we're getting back a string, and this is the hexadecimal value of that string. Now, for exemplary purposes, I mean, what we could do, even though, I mean, I'm not recommending this, but let's just, I think to kind of show to kind of go full circle and just show like how this is useful. Let's just do it in the extractor. So I'm gonna import decode parameters here from ethfun, and I'm gonna say that so instead of just stringifying anyways a string, which makes not that much sense, let's just immediately decode this parameter. So decode parameters, and according to the docs, where do I have to here? So we need to pass an array of the expected types that we are getting. So it's just a string, and then we are expected to pass the parameter to be decoded. And then actually, I think one speciality is that decode parameters actually different to Web3. It returns an iterable object. So we're gonna return the token URI, and we're gonna pattern match it against the list, and then we're just gonna write token URI. Now I made a mistake somewhere. Here. So okay, so this I guess it should work. To kind of restart basically the crawl and to not get all of this information, I'm just gonna delete the first crawl file that we had, and I'm just gonna rerun the crawler, and it looks okay. I don't see any errors for now, and when we stop the crawl, what we should expect now is like IPFS links, and indeed, so these seem to be all of the different CIDs, and we can also probably just try these if we go to an IPFS gateway. I'm not exactly sure if this is correct. If this is the correct gateway, and also how fast it will be. But okay, so it loaded, and as you can see, yeah, there's definitely, this looks like music stuff. There's an image IPFS, there's some lossless audio. Yeah, I think this looks good. So yeah, so that, I think that would be how to write a extractor strategy. I think just to summarize, although I've done it now, I didn't really do it in this demonstration. The point of separating extraction, transformation, and later also loading is such that we can always invoke each strategy without requiring like state or input from other strategies. And also where, if let's say sound were to change, I guess they won't ever change it, but imagine they would change the outcome of this interface, then preferably we want the extractor to first fail, or if they change, the formatting, let's say, of the token URI, what you are getting back, then the transformation should fail. And so this is kind of like a structured approach to data engineering, data extraction, and that we want to follow that, because what it allows us is to have like this staged crawl where we can like stop the crawl at any point in time, and we can restart the crawl, and the state of the crawl essentially is really just the data that we're writing into flat files. So yeah, that was I will make this code available probably through GitHub, and also be sure that I will try to remove the key that I have leaked. And yeah, that's it. I will stop sharing my screen now. Thanks for joining and hearing about this, and I'm happy to answer questions now.
Yeah, I think that was super useful. Obviously, I didn't understand that much as a non-technical person, but hopefully people who are technical learned something from that. And as mentioned, obviously we're going to make this available. If people jumped in late or whatever, they'll be able to watch the video back. But yeah, if there's any questions at all for Tim, if not now, then obviously feel free to drop them in the chat. We're usually pretty active in Discord. If no questions now, then I reckon we're just at time, so we can knock off this session. And yeah, see you on Discord if there's no questions now. Nope, cool. All right, well, thank you everyone for joining. See you later.